Hi, in this video we are going to be going through solving equations using indices. So in these kind of equations you notice that the thing that we're trying to find is in the power. So no longer are we solving equations like this where the variable is in the base, x squared, and we know some techniques around doing that, in this case square rooting both sides, but we're talking about equations where the variable is in the power. So 2 to the power of x equals 16. So these first couple that we're looking at here is just really easy to just write down the answer with a little bit of manipulation. So in this case we don't need any calculators. 2 to the power of 4 is 16, so I can just write down x equals 4. 3 times 5 to the x is 375. First of all, divide by 3, so you get the 5 to the x on its own. So in this one here, if we divide by 3, we get 375 divided by 3, which is 125. And then I can say straight away, okay, 5 cubed is 125. So that's how you would do B. C, 4 to the x minus 5 is 11. Again, a little bit of rearranging and makes it really easy. 4 to the power of x is 16, and then we can say x is 2. 4 squared is 16. Getting a little bit trickier for D. 8 to the power of x equals 4. Just like before with our indices, when we were simplifying, writing everything to the same base makes things way easier. Same thing here. I'm going to make this 8 as 2 cubed, and I'm going to change 4 to 2 squared. Remember, this is all without my calculator. So power to a power on the left hand side gives me 2 to the 3x, and on the right hand side 2 squared. Now, because the bases are the same, then these exponents must be the same. So my next line is just to write that 3x is equal to 2, so x must be equal to 2/3. So that one there is a little bit trickier than the last one, but that's the technique you use. So if you have bases of 3 numbers with base 3, so if you have 3s or 9s or 27s or 81s, you all convert it so it's all base 3. Part E says 25 to the power of 3x minus 1 is equal to 0.2. First thing I'm going to do is write this as 1/5, which you could say is 5 to the minus 1. On the left hand side, I'm going to rewrite 25 as 5 squared. Alright, power to a power on the left hand side, so we're going to multiply 2 by 3x minus 1, giving us 6x minus 2. And on the right hand side we've got 5 to the minus 1. Again, because now we've expressed both of these with a base of 5, we can say that the exponents are equal to each other. So 6x minus 2 equals negative 1. Add 2 to both sides, and our answer here is 1/6. Notice I've never gone for my calculator here, so these are the kind of questions you may get in the calculator free section. Okay, in the next ones here, ones where the base are unknown. Now these are less common kind of questions for this, but I'm going to deal with these kind in some other questions as well. We know how to do part A. X squared is 36. So x is plus or minus the square root of 36. Plus or minus 6. If we have x to the power of 0.5 or x to the power of a half equals 9, again, we understand that half means square root. Power of a half means square root. So now to solve this equation, we just square both sides. So x is equal to 81. If x to the negative 1 is equal to 9, that's 1 over x equals 9. If we multiply both sides by x, we get 9x equals 1, and x is equal to 1/9. In D, 3 plus x to the half is equal to 7. So the square root of x must be 4. So x must be 16, squaring both sides. E's the trickiest one here. X divided by the square root of x is x divided by x to the half. So if you say now on the left hand side, x to the power 1 divided by x to the power of a half, subtract the powers, you get x to the power of a half. equals 7, and we know that means the square root of x is 7, so x is 49. Okay, cool. So I've done a number of examples here using basic index laws to help us solve equations. These ones are a bit trickier. I'm going to use the same technique. So in this one here, obviously I want to write everything with a base of 3. So 9 I'm going to write as 3 squared, and 81 I'm going to write as 3 to the power of 4. Now if you're thinking I didn't know that, it's a really good idea to know your first 3 or 4 bases for 1, 2, 3, 4, 5 and 6, those kinds of things. It's really helpful. So 4 squared is 16, 4 cubed is 64, etc. Those kind of numbers are really helpful to know. Okay, so 3 to the 2x, power to a power, multiply here, we've got 3 to the 2x minus 2, and over on the right 3 to the power of 4. Okay, the index laws on the left hand side, the bases are the same, so we can add the indices. So this is 3 to the power of 4x minus 2. And now I've got it in this step where the base is the same on both sides, I can just now say that is equal to that. So 4x minus 2 is 4, 4x is 6, x is 6 over 4, 3 over 2, or 1.5. Any of those answers is good for that one there. This is a different kind of problem now. Looks really strange at the start, but we've also done one similar to this when we were doing trig equations that transform themselves into quadratic equations. Here's the indice or exponential version of that little routine. What I'm going to do here is say let y equal 3 to the x. Alright, and you're going to see that this is now a quadratic equation. So 3 to the 2x we can write as 3 to the x squared, right? Because we've got a power to a power, so here we just multiply those powers. So 3 to the x I've just said is y, so that's actually y squared. So this original equation becomes y squared minus 10 times y plus 9 is equal to 0. And all the time in the exam, I think, or hope, in any exam you get, that this will be a nice quadratic that can factorise. You may need to use the quadratic formula, but I'm betting that it'll be a nice one that factorises. So two numbers that multiply to give me 9, add to give me negative 10. I'm betting that those numbers are 9 and 1. And in fact we need negative 1 and negative 9 to get negative 10. So that works. That's the correct factorisation. So the solution is y equals 9 or y equals 1. Now let's go back to our original, that y was equal to 3 to the x. Remember, we're trying to solve this equation in terms of the variable x. So I'm going to write, if y is 3 to the 9, that means 3 to the x is equal to 9, or 3 to the power of x equals 1. So we just solve those individually. This one here, it's easy. 3 squared is 9, and over here x to the 3 to the power of 0 is equal to 1. So there's our solutions, 0 and 2. It's often just a good idea to check back in your original equation whether those work. So for example, let's try 0, and here we get 3 to the power of 0 minus 10 times 3 to the power of 0 plus 9. So that gives us 1 minus 10 plus 9, and that is 0. So that's correct. And if you also substitute our answer of 2 in there, you'll also get a correct solution. So it's worthwhile just checking back in your original equation to see that your solutions actually work. Sometimes also one of these solutions may end up being negative. So when you factorise the quadratic, so you might get something like 3 to the x equals negative 1, for example. There's no solutions for that. So it just 3 to the power of x is always going to be a positive number, so you can't get any solutions for that one there. But in this case, we've got two solutions of 0 or 2. Here's another one where we're undoing the cubed. So before we had squared, x squared equals 36. How do you undo cubed? And the way that you do that is you cube root both sides. So there's a couple of ways of thinking of this. The cube root of both sides will give us the answer. So the cube root of p cubed is just p. The cube root of 216 is 6. So you can also check that on your calculator, the cube root of 216, or and again, that's another nice one to know, that 6 cubed is 216. The other way you can think of this is you've got p to the power of 3, a power of a third to both sides is what will solve this equation. Okay, on the left hand side here, power to a power, 3 times a third is p to the power of 1. And 216 to the power of a third is 6. This is a similar example. X to the 2/3 equals 9. Now how can we undo 2/3 so that we end up with just x to the power of 1? That's what we want. So the solution here is to go to the power of 3/2 to both sides. You'll see that when we multiply those numbers there, 2/3 times 3/2, we get 1. And on the right hand side, 9 to the power of 3/2 is the square root of 9 cubed. Often we don't write that so we normally write it like that. It's the square root of 9 cubed. Now I don't know what 9 cubed is, perhaps I should, but I do know the square root of 9 is 3, and I know 3 cubed is 27. So the answer to that one is 27.